Mathematics made easy, no more fear. Mathematics made easy, no more fear. Target online class, we got you. Wherever you want it from, we got what you need. Target online class.
Good day, viewers all over the world. You are welcome to Toydel online class. Today we want to look at the introduction to operation research. So we want to introduce operation research today. And of course, this is one of the concepts that we have in the higher level, that is at the university level. It's one of the concepts that we have in mathematics. So I will just try to rush through some of the information about operation research. I'm just introducing operation research for today. So let me just rush through the beginning of operation research. The beginning of the activities or activity called operation research has generally been attributed to military service era in the World War II. That is, these concepts come into being during the World War II, when there was a scarcity of some of the equipment and management of the world. So the British and the US military management called upon large number of scientists to apply a scientific approach to dealing with this and other strategy and tactical problems. So during the war, there was a lot of shortage. You know, when there was war, a war situation is different from the normal situation. So they actually have challenges. So the British and the US Army then actually call upon scientists to actually help them to actually resolve some of the problems that they have during the war, during the Second World War. And that was actually gave birth to operation research. So in effect, they were asked to do research on military operations. This team, that is the team or teams of scientists that do that research, they were the first OR team. So operation research in this course, we'll be referring to operation research as OR. That will be the abbreviation that we are going to be using under operation research. So by the early 1950s, this individual had introduced the use of OR to a variety of organizations in business, industry, and government. So OR actually became popular after the Second World War. So early 50s, when they look at the strategy, how they are able to manage the situation during the Second World War, then they begin to introduce these operations to other sector of the economy, like finance. They introduce it to finance. They actually introduced to so many organizations, industry, education, government, etc. So, but for the purpose of this course, we are going to concentrate on mathematical modeling under operation research. Okay, and there are many standard tools that we use in operation research. There are many standard tools. The first one is linear programming. Linear programming. So we'll be talking about all this in the course of study. The second one is we also have dynamic. We have dynamic programming. We'll be also talking about queen theory. Queen theory. We'll also talk about inventory theory. Inventory theory and etc. So we'll be picking one of these concepts, one after the other, as we proceed in this course. So we talk about linear programming, we talk about dynamics programming, we talk about queen theory, inventory theory, and some other concepts or tools that we use in operation research. So those are some of the tools that we'll be talking about in the course of this this course, operation research. So we should please take note of that. So I just want to do the general overview of OR modeling approach. That is, what are the approaches that we use under OR modeling or under OR modeling. So I just want to do the overview. That is a kind of summary of how we actually approach any problems under OR. So the bulk of this course is devoted to mathematical methods of OR. OR is more than mathematics. So we have so many approaches for it because there are so many software on OR. So that just input our data, then we get the results. You know, the world has become a global village, and not only that, we actually have increase in technology. So we have many ready-made software that has been testing to be that has been proven to be okay for OR. But for the sake of this course, because we are taking this course OR in mathematics, we are using mathematical approach to OR. So I just want to do the overview of OR modeling approach, because it's more of a under operation research. We do a kind of modeling. So we model some concept. So let's just look at the overview of how this course will be structured. So the bulk of this course is devoted to mathematical methods of OR. However, it does not imply that practical OR studies are primarily mathematical exercises. That is, OR is more than mathematical approach. That's what we are trying to say. But for the sake of this class, because this is a mathematics class, we are going to look at the mathematical approach to OR. So as a matter of fact, the mathematical analysis often represents only a relatively small part of the total effort required. That is, I'm trying to say that we are going to consider a very minute aspect of OR, because we are going to base whatever we are going to discuss under operational research in this is a mathematics class. So we look at the mathematical angle. But what I'm trying to say is that if you get standard textbook on OR is more than mathematics. They apply OR in economics, in business, in engineering, even in military. So OR is a very large concept that has been actually welcomed in almost all the facets of life. So, but we just want to concentrate on the mathematical aspect. So, as a matter of fact, the mathematical analysis often represents only a relatively small part of the total effort required. So, the purpose of this overview, that is what I'm about to state now. The purpose of this overview is to describe all the major phases of OR. So, we just want to look at the phases, that is the steps of OR, phases of OR. That's what we want to talk about. But we are going to concentrate on the one that has to do with mathematics. So phases of operation research. Phases of operation research. Phases of operation research. So the first one is we are going to define the problem. That is, for us to be able to introduce OR, there must be a problem. There must be problem of interest. So we have to define the problem of interest to represent. No, we are going to define the problem of interest and gather relevant data and gather relevant data. So in any problem in life, we must define that problem, because if you don't really understand the problem, then to provide a solution will be almost impossible. So under phases of OR, the first thing that we do there is that we have to define the problem of interest. Of course, all the problems of interest in this course will be mathematical problem. That is, but I want to look at the overview of OR generally. So we define the problem of interest and gather relevant data. Then the second point is that we formulate a mathematical model to represent the problem. So once we define the problem, then we formulate a mathematical model to represent that problem. Okay. The third one is that we develop a computer-based procedure for deriving solution to the problem from the model. So in this case now, as I've said earlier on, we have a lot of software that has been testing, that has been proven to be okay. A lot of software on OR. So the third one is that we have to develop. We are looking at the general overview of OR. So we develop a computer-based procedure for deriving solutions to the problem, from the model. So there'll be a kind of model that we use to represent the problem. Then once we are able to do that, then we test the model and refine it as needed. The next one is that we test. There's need for testing. We test the model. And refine it as needed. We refine it as needed. So the fifth overview is that we prepare for the ongoing application of the model as prescribed by management. Okay, once we test the model and refine it as needed, then we don't prepare. There's need for preparation. We prepare for the ongoing application. We prepare for the ongoing application of the model. As prescribed by management. And the last step is that we just go for implementation. Then we go ahead and implement. So we go for implementation. So these are the overview of OR modeling approach. So these are the overview of OR modeling approach. So we are expected to know all this. We are expected to know all these concepts. So we are expected to know all this. So we are expected to know everything that I've just said. So we are expected to know all this. So please, let's take note of the overview. Let's just take note of what I've just said. So these are the phases of OR. But as I've said earlier on, for the purpose of this course, we'll concentrate on the formulating a mathematical model. That is, we formulate a mathematical model to represent the problem. So we are going to concentrate on formulating a mathematical model. So how do we formulate a mathematical model? Because under this course, we're actually talking about modeling. So we are going to do a lot of modeling in this course. So how do we formulate a mathematical model? So it now depends. So most of the problems that we are going to solve in this course, OR, as far as this course is concerned, are mathematical problems. But that doesn't mean that we don't apply OR in other facets of life. OR is very important in economics, statistics, many areas. So let's just look at formulating a mathematical model. So what do we do? Then we must understand the concept of modeling. Formulating a mathematical model. Okay. So what do we do? So after decision makers problem is defined, the next phase is to reformulate this problem in the form that is convenient for analysis. You know, there are some theoretical terms that we cannot actually solve. So we have to formulate it in a situation whereby we'll be able to analyze it. And that's the purpose of modeling. So the convention OR approach for doing this is to construct a mathematical model that represents the essence of the problem. Models or idealized representation are integral part of our everyday life. That is when we talk about models. When we say we want to formulate a models, you know, it's an idea or idealized representation. Representation. So that is, if you have a problem, we have to come up with a model. We have to come up with a model. Model or idealized representation are integral part of our everyday life. Common examples include when we model a portrait, a globe. We can actually model a biological problem. We can model in finance. We can actually model in electromagnetism. There are so many models. So just know that model is that when you talk about model, we are talking about idealized representation of the real problem. So model plays an important role in science and business, as illustrated by the models of atom, models of genetic structure, mathematical equations describing physical laws of motion or chemical reactions, graphs, organizational charts, and industrial accounting. So mathematical models are also idealized representation, but they are expressed in terms of mathematical symbols and expressions. Mathematical model now that we first talk about under OR, they are expressed in terms of mathematical symbols and expressions. For instance, the mathematical model of a business problem is the system of equations and related mathematical expressions that describe the essence of the problem. Thus, if there are n related quantifiable decisions to be made, if you have n related quantifiable decisions to be made, they are represented as decision variables. They are represented as decisions variables. They are represented as decision variables. That is, we can have something like, if there are if we have n related quantifiable decisions, this decision will be represented as decision variables. We can say it's x1, x2, ... up to xn. This is how we are going to represent it. Because there are, if we have n related quantifiable decisions to be made, S1 can be the first decision, S2 can be the second decision, up to the last decision that we actually want to make. So that is what we are supposed to do. So that is that about decision variables. So they are represented as decision variables, as we have talked about, whose respective values are to be determined. That is, we are going to get values for all this. We can actually get value for all this at the end of the day. So the appropriate measure of performance is then expressed as a mathematical functions of these decision variables. So what we are talking about, that once we have the decision variables, then the appropriate measure of performance is then expressed as a mathematical function of these decision variables. That is, for instance, we can say P, maybe price. The price can be equal to maybe 3x1 plus 3x2 plus ... plus maybe 7xn. So in this case now, these are the decision variables, x1, x2, x3. These are decision variables to be determined. But let's say this is price. Maybe this is for one commodity. So if there are 3 commodities at this price, we can have, let's say this one is 8. X2 now, the coefficient here is 8. We are talking about 8 of this commodity. ... simply means there are some values in between. Then the last one probably has if the last variable is just maybe 8 or 9, we have x9. Then the 7 here is the coefficient. So this is what we have here. It is called, what we have there, it is called the mathematical function. Now this is a function. Once there is equality sign, we are talking about function. So these are decision variables being represented. These are mathematical functions. Okay, that is how we develop a mathematical model. So the function is called the objective functions. This mathematical function now, all these entries here are called decision variables. Then these functions are called objective. They are called objective functions. So in our next class, we are going to see how we are going to take problems, and we see how we are going to come up with decision variables, objective functions. So those are some of the terminology that we'll be using under operation research. So those are some of the terminologies that we'll be using under operation research. So we should just note. Let's note that there are some of the terminologies that we're using under operation research. Okay, so these functions are called the objective functions. So any restriction on the value that can be assigned to these decision variables are also expressed mathematically. You know, there could be restrictions, of course, when we are dealing with, for instance, in financial world, there will always be a restriction. Even in every facet of life, we always say standard and restriction. So there will always be a restriction. So any restriction on the values that can be assigned to these decision variables are also expressed mathematically, typically by the means of inequalities or equations. That is, we can actually set restriction, and those restrictions, they are actually called constraint. Those restrictions are actually called, for instance, if we can have something like x1 plus 3x2 plus 3x1 x2 plus 2x2 less than or equal to 10. We can have something like this. So with this less than or equal to, this objective function has been restricted. So anything that is not equal to this or less than 10 will not be factored in. So this is a kind of restriction here. So we place a restriction on that objective function, which actually makes sense in the real world, because there are restrictions in every facet of life. So any restriction on the value that can be assigned to these decision variables are also expressed mathematically, typically by means of inequalities like what we have on the board, or equations. So such mathematical expression for the restriction are often called constraint. Once we have this kind of restriction, these restrictions are called constraint. So these are some of the terminologies that we'll be using in OR. So these are called constraints. So when we set restrictions, we actually call those restrictions constraint. So the constants in the constraints and the objective functions are called parameters. That is, this objective function, all these constants here, 3, 8, 7, these are constants. 2, 3, 10, all these are constants. These constants are called parameters. We call them parameters. They are called parameters. Parameters. We've talked about, we have actually talked about some of the terminologies that we use. We've talked about decision variables. We've talked about objective functions. We've talked about constraints, and we have also talked about parameters. So they are called the parameters of the variable. So the mathematical model might then say that the problem is to choose the values of the decision variables so as to maximize the objective function, subject to specified constraint, such a model or minor variation of it, typified model used. So these are type of model used in OR. So these are some of the concepts that we'll be discussing. So by the time we come fully, I introduce by the time I'm going to introduce each of what we have discussed today. You know, I said we have so many tools that we use in operational research. We have linear programming, dynamics programming, Queen theory, inverted theory, etc., and so on. So by the time we are going to introduce some of these concepts, I will briefly explain some of these concepts. Then we come up with example so that we're able to solve. We see real life. We come up with example. So for the theoretical part of OR, you can just lay your hand on good textbooks, just get good textbook on OR, have proper understanding, coupled with what we have discussed today. They will now come with examples and exercises on mathematical aspects of modeling, modeling in operational research. We also have computer-based modeling. There are so many modeling, but everything that we are going to talk about under operational research will be restricted to the mathematical aspects of operational research. So I would love to stop here because of our time. This is just the introduction to operational research. By the grace of God, in our next class, we are going to concentrate more on the aspect that we want to talk about, mathematical approach to operational research. So you can just send this to friends and family and encourage them to subscribe to my YouTube channel. Thank you and God bless you all.